All right, here we go. A sandwich shop has 3 types of bread, 4 types of cheese, and 18 different toppings. How many unique sandwiches can be made in the shop? Be sure you show how it works. So for this one, we're going to use something called the fundamental counting principle. And the fundamental counting principle says that if I want to figure out the number of combinations of something, I just take the different parts, 3, 4, and 18, and I multiply them together. So showing my work, 3 times 4 times 18. 3 times 4 times 18 is 216 possible sandwiches. Unique sandwiches. Boom. Question 2. So remember, you should be pausing the video, trying the question, and then go ahead and seeing if you're right. I also shared a document with you if you wanted to do this on a hard sheet of paper. Over spring break, you have decided to plan a 3-day trip to Florida, Thursday, Friday, Saturday. That actually doesn't matter. The probability it rains is 50%. Each day is independent from the other. That actually doesn't matter very much either for right now. It will matter eventually. Make a tree diagram to show your sample space. So we're going to say that it's Monday, or I guess it's not Monday. Undo. My sample space is going to look like this. It's either going to be Thursday, Friday, or Saturday. So Thursday, it can either rain or not rain. We'll call it dry. And then Friday, it can either rain or be dry. Or if it's dry, it can either rain or be dry. And then finally, we'll move Saturday up a little bit because it's going to run into my tree diagram. It can either rain or be dry. Rain, dry, rain, dry, rain, dry. So that makes sense because we have 2 different options in the first day, 2 different options in the second day, 2 different options in the third day. So using that FTC, or the fundamental counting principle, 2 times 2 times 2 is 8 different combos. What's the probability it rains all 3 days? So it rains all 3 days right here. 1, 2, 3. That's the only scenario where it could rain all 3 days. So that's going to be 1/8. What's the probability it rains 2 of the 3 days? So that's going to be a little bit different. So we have to figure out where it's going to rain 2 of the 3 days, exactly 2 of the 3 days. So this is still 1/8. 2 out of 3 days. So let's see here. It rains here and here and here. So that's going to be 1. And then it rains, dry, rains. So there's 2. Rain, dry, dry. Nope, only 1. Dry, rain, rain. There you go. There's 2 of them. Drain. Doesn't even sound like a word anymore. Dry, rain, dry. That's only 1 rain. Dry, dry, rain. That's only 1 rain. Dry, dry, dry. That's only 1 rain. So it's going to rain 2 out of the 3 days. 1, 2, 3 out of 8. The probability would be 3 out of 8. That one's a tough one. Probably the toughest one. True story, I looked it up. Last week, AMC was trading for roughly $5 a share. This week, after some crazy shenanigans, AMC is now trading for roughly $7.50 a share. What's the percent change? So remember, the formula for percent change is new minus old over old. So here's my new, and here's my old. So new minus old, let's do it. $7.50 minus $5 divided by, now here's where you're going to mess it up. We're going to divide by the old, so divide by 5. So that's going to give me 250, positive 250 over 5, which gives me about 0.5, or 50% growth. And we know that it's 50% growth because our percent change is a positive number and not a negative number. 0.05 or 50% growth. There you go. The basement refrigerator contains only juice and milk. That's it. A fully stocked fridge has 14 juice boxes. Sounds good. And 10 milk cartons. Not as good. 3 drinks are always picked at random in this example, and they are consumed, which means that we're not replacing. So these are actually called dependent events, and we're going to have to adjust the different probabilities. So find the following probabilities. All 3 selected are juice boxes. So it goes juice, juice, juice. This is how I do them. So we got a total of 24 different drinks. We have 14 juice boxes out of the 24. And then I go ahead and I drink one. So now I have 13 juice boxes out of the 23 that are left. And then finally, I drank one of those again. So I have 12 juice boxes out of the 22. Let's figure out what that is real quick. 14 times 13 times 12. 2,184 divided by 24 times 23 times 22, which is 12,144, which is equal to about 17.9%, so about roughly about 18% of the time. Pretty good. The first drink you select is a juice box, is juice, followed by 2 cartons of milk. So again, it goes juice, milk, milk. And again, we're not replacing them. So juice, that's going to stay the same, 14 over 24. Times, now milk is a little bit different. We got 10 over 23. And then we drink one of the milks, so it's going to be 9 over 22. Multiply the top, multiply the bottom. 14 times 10 times 9, 1260. Divided by 24 times 23 times 22. We already know that one, 12,144. So if I do 1260 divided by 12144, slightly less, about 10.4%. At least, so what's the probability if we drink 3 of them that I get at least 1 juice box? So at least 1. So if you think about it, what you'd have to do is you'd have to take the probability of drinking 1 plus the probability of 2 plus the probability of 3. Now, this is kind of tricky. The only probability that we're missing here, so this would take a lot of work doing it this way. The only probability that we're missing here is the probability that we didn't drink any juice boxes. So when you're doing an at least question, the way that I would do it is I would do 1 minus the probability of 0 juice boxes. So let's find out the probability of 0 juice boxes real quick. So that means it goes milk, milk, milk. So we got 10 out of 24. We drink 1. We get 9 out of 23. We drink 1. We get 8 out of 22. We adjusted for the dependence so we can multiply them together. 10 times 9 times 8 gives me 720 over 24 times 23 times 22. That gives me 12,144. I don't know why I keep doing it. We keep getting the same thing. So the probability of not getting any juice boxes is 720 divided by 12,144, about 6%. That's this right here. And now if I want to find the probability of at least 1 juice box, I do 1 minus that 6%, and that gives me 0.94 or 94%. Boom. Oof. All right, here we go. let's fill out the rest of the table real quick. So we have everything we need. We know that these need to add to 1, so that'll be 0.6. We know this will be 0.8. We know that 0.04 plus some number is going to be 0.4. So if I want to find the intersection of not B and A, that's going to be 0.4 minus 0.04, which is 0.36. And then you can figure out the rest from there. So this will be what is that, 44? And this will be has to add to 0.2, so that'll be 0.16. Notice the guts, or the conditions, will add to 1. The columns or the margins will also add to 1. So now you can figure out all the probabilities. Probability of not A, 0.8. Probability of A union B. So union, remember, union means or. So that's going to be the probability of A, which is 0.4, plus the probability of B, which is 0.2, minus the intersection, which is 0.04. So that's 0.6 minus 0.04 is 0.56. Not B intersect, so this means not B and A. So not B and A run into each other right here at 0.36. And then finally, the probability of A given B. So given B, given that 0.4, needs to go in my denominator. The probability of A, a lot of people think it's 0.2. It's not. It's the intersection 0.04. So 0.04 divided by 0.4 gives me 0.1. All right, 2 more. I got to keep it under 15. Let's see if I can do it. So here we got to fill out the chart. Probability of A is going to be 0.75. And the probability of B is going to be 0.25. Or 0.12, excuse me. And the union, so these 3 tiles added together, is going to be 0.78. So remember, the union is equal to the probability of A plus the probability of B minus the intersection of A and B. So let's plug in some numbers now. We have the probability of the union equals the probability of A, which is 0.75, plus the probability of B, which is 0.12, minus the intersection. And then we can do some simple algebra to figure out what the intersection is. So we got 0.78 minus 0.75 minus 0.12 times -1. We get this to be 9%. So find the intersection. 0.09. And now that you have 0.09, you can figure out the rest of the information. We didn't need 0.09 for this one, 0.12. We don't need it for this one either, 0.88. This will always be 1. Since this is 9%, we have 75% down here, so that means that we have 66% left. 9%, that means we have 3%. I did it again. Rats. 0.03. And then finally, this will be 0.03 plus some number gives me 0.25. That'll be 0.22. And again, these 2 should add, or those 4 should add up to 1, and then the margin should add up to 1. Finally, find the probability of B given A. So given A, which is going to be 0.75, the probability of B is going to be 0.09. 0.09 divided by 0.75, 0.12. That is just a coincidence that that's also the probability of B. Let me make sure I did this one right. I don't know if I did this. Probability of A given B. I always do that. I'll have to do a little voiceover. Probability of A given B. So given B, 0.2 is in the denominator. Probability of A is 0.04 over 0.2. It's going to be 0.2. Again, just a coincidence. All right, the last one, I'll just have to post the answer. Give me a second. Boom. Boom, there's the rest of the chart. And then finally, the intersection of A and B is going to be 0.17.